So if we're supposed to find the partial fraction decomposition for this guy over here, then we have to note that there's a repeating linear factor. Y plus 5 comes up twice. This could be written as y plus 5 times y plus 5. When you break that expression down, I'm just going to move it over. Actually, you know what I can do? We're going to set that equal to a over 5y minus 1 plus b over y plus 5, and then plus c over y plus 5 squared. Okay, and that's what we've got to solve for is a, b, and c. That's the goal of partial fraction decomposition. You rewrite it so that it's several rational expressions being added together. And because y plus 5 comes up twice, you need to consider it to the first power and to the second power. Because now, if you were to multiply both sides of this equation by the denominator, you get negative 3y squared minus 14y plus 57 on the left. And here, you get a times y plus 5 squared. And then you'd get b, the y plus 5 would cancel out, so you'd have 5y minus 1. And then you have another y plus 5. Oh, I'm running out of room. Move that. Okay. And then c is going to be the y plus 5 squared is getting canceled out, so you're just going to have c times 5y minus 1. Again, that's because we're multiplying both sides of the equation by 5y minus 1 times y plus 5 squared. Okay, so to solve, you want to do this just like you do a regular partial fraction decomposition problem where you're picking certain values for y that are going to make it easier to solve. Like I'm going to start with y equals 1/5. Because if you plug in 1/5 here, 5 times 1/5 is 1. 1 minus 1 makes 0. Same thing over here. This also becomes 0. So it's making a lot of things cancel out, so we just have a to deal with. And instead of 1/5, I'll do 0.2. Hopefully it'll come out to a whole number, but we'll see. So we're plugging in 0.2 everywhere. In other words, plugging in 1/5. So I'll plug in left to right. I did 0.2 squared times negative 3. It was negative 0.12. Then 0.2 times 14, that's 2.8. Then we got 57. Can make that bigger so it's a little easier on your eyes too. And then on the right side, we're plugging in 0.2 into y. And then it's supposed to be squared. So we got 27.04 times a. Because all these turned out to be 0 because of our choice in y. Left side, cleaning that up a bit. 2.8 plus 57. Got 54.08 on the left side. If you divide both sides by 27.04, you get 2. So we just solved A is 2. To find out B, we got to pick a number. It's going to make everything cancel out except for B. I don't think we can pick a number because 1/5 would make B cancel out. So let me think about this for a second. So we've got A. Instead of going to B next, let's solve for C because B is going to be a little bit more complicated. Since we can't plug in a certain value for y to make the A and C cancel out, that's why it's best to leave B until the end. We can find out what C is. If we plug in y equals negative 5, then that's going to make this term turn to 0 and this term turn to 0. So we're plugging in negative 5 everywhere. Negative 5. And then over here, if you plug in negative 5, that becomes 0. Negative 5, that becomes 0. So plugging in negative 5 over here. Okay, and then I'll take my calculator out. 25 times 3, so that's negative 75. So we got negative 14 times negative 5, that makes positive 75, that makes 0, and then that's plus 57. Right. So we got 57 on the left side. So we got negative 26 on the right side. Oh, it makes me think I did something wrong. Let me just double check. 5 squared is 25. 25 times negative 3 is negative 75. And then 14 times 5. Oh, I messed something up. Okay, so negative 75 plus 70 is negative 5 plus 57. On the left side, it should be 52. And then if you divide negative 26 from both sides, you get C is negative 2. We've got A. We've got B. We're closer to solving this whole thing. We've almost got this all complete. We just need to know what B is here. I think I said we got B. We don't have B. We have A. We have C. We've got to go find out what B is. Okay, let's write it out. Negative 3y squared divided by 14. I'm just copying the left side. And then we had 2 in for A. We've got B that we don't know. And then C is negative 2, so put a minus 2, 5y minus 1. So to make this equation a little simpler, let's see if we can combine some like terms, because now that we know what A and C are, we can distribute. That's supposed to be squared, not y. So y plus 5 squared, that whole parentheses being squared means it gets multiplied by itself. So this parentheses squared should be y squared plus 10y plus 25. So it's when you distribute that 2, it's going to be 2y squared plus 20y plus 50. I guess we could distribute there. And then over here, distribute that negative 2, you get negative 10y plus 2. And then if we combine terms, we've got 2y squared plus 10y plus 52, and then plus all this stuff here. And we still have it set equal to this stuff on the left. I'm just going to wait a second. Because if you factor out a 2, maybe we can factor this to something nice. Oh, no, we can't. Two numbers can't multiply, be 26, and that to be 5. Let's see. You can just pick a number for y. Easy to work with. If you plug in y equals 1, that won't make anything cancel out, but we'll at least have an equation to solve for b. Or wait, y equals 0 is probably even easier. Yeah, let's plug in y equals 0 to the left and to the right. If you plug in y equals 0 to the left side, you get 57. Y equals 0 to the right side, this is 0, this is 0, we got 52. And then we got 5 times 0 minus 1. And then we got 0 plus 5. So 5 times 0 is 0. 0 minus 1 is negative 1. And then it's 5 in the other parentheses. So subtract that 52 from both sides. We get 5 equals negative 5 times b. Or in other words, b equals negative 1. Okay, so we've got it now. If you plug in negative 1 in for b, what was A? A was 2, and C was negative 2. That's your partial fraction decomposition. So when there's a repeating factor, the tricky part is solving for one of those variables. You can't pick a number to make the other terms cancel out like we did before. But if you solve for the other letters, for A and for C, then you can just choose your own value for y, like I chose y equals 0 to make the equation nice and simple.